Hello class, today we're sharing a new unit, logarithms. A logarithm is just the inverse of an exponential function. And an exponential function is just any function whose x, or the input variable, is in the exponent. So we're dealing with exponents in this unit. Now, I mentioned that logarithms and exponential functions are inverses of each other, and we have two different forms that we can write these functions. We have an exponential form, which states that y equals b to the x, and b is some base value. Anything that is raised to a power x, we just call a base. Now, we can write either an exponential function, and it's solved for y, or if we want to solve for x, we write it in logarithmic form. And this is x equals log base b of y, and you can see the base is still in there. So notice what this is saying. This is saying y equals some base to an x power. This is saying x equals log base b of y. So we can think b to some power is equal to y, right? b to some power is equal to y. They're both saying the same thing, they're just solved for different variables. One solved for y, one is solved for x. The reason why this is useful is because sometimes we'll want it solved for y, and sometimes we'll want it solved for x. So that's a very special relationship there. Now, I wrote a little note here. In log form, so in logarithmic form, b won't be written if b is equal to 10. For instance, if we have this function x equals log of 64, there's a little invisible 10 there. It's just a standard notation. If it's 10, you just don't write it. Okay. So let's kind of just review exponents, because this has a lot to do with exponents. So what do exponents do? Well, what it basically tells us, it tells us to multiply our base by itself that many times. So in this case, our base is 3. So 3 to the 4th power is really equal to 3 times itself 4 times. That's what 3 to the 4th power is saying. And 3 times 3 times 3 times 3 is 81. Likewise, 2 to the 3rd power is saying raise our base 2 to the 3rd power multiplied by itself 3 times. So 2 times 2 times 2 is 8. So that's just good review to remember what exponents do. So here let's go down to these examples, and here we're going to be solving for variables. Well, in this case, solving for x. Now, you might notice, well, in logarithmic form, it's already solved for x. So why don't we put this into logarithmic form, and we can see what log base b of y is. Well, the problem there is that logarithms, it's to get it, it's the exact same thing as putting it into exponential form. And exponential form is actually easier to read. Now, to find an exact logarithmic value, we would need a calculator that has logs in it. Now, a quick little note. I know that your phones, the smartphones, when you turn them sideways, it has a log button, but that is only for log base 10. Notice that if you try it on your phone, you can't input your own base into it. Likewise, with these calculators that we have here at the school, you have two log buttons. You have this log, which is the automatic base 10, and then you have, you can hit math and then go down to log base. This is the one you would need. So, but since we don't have that capability learning from home right now, we don't have the option of being able to plug this into the calculator. So we're going to be doing this whole unit without the calculator. Okay? So going back to that, just a little note, solve for x. Here, this is what it's asking. 2 to what power gives me 8? So let's think about it. I mean, if you're not too great if you're not too great at doing it in your head, I like to write it down. So 2 to the 1st power is just 2, right? Let's see, 2 squared is 4, 2 times 2. And 2 cubed is 2 times 2 times 2, which is 8. So in this case, our x value should be equal to 3. So x is equal to 3. Not that bad, right? Now let's look at it in log form. As I said earlier, we can think of this like this. Our b to the x is equal to y. So let's think about this. 3 to the x power equals 81. So what we're really asking ourselves is 3 to what power is 81? Or if you're more comfortable, you can put it from logarithmic form into exponential form. It's the exact same thought process, it's just the numbers are put in a different spot. So if we were to put this into exponential form, let's see, it starts off y, and our y for our log is over here, so it's going to start off 81. Well, I'm going to put the b of x first, just to keep it in this form. So our base is 3, so 3 to the x power is equal to 81. So 3 to what power gives us 81? Well, again, if you're not too great, we can do it like this until we do get good at it. So 3 to the first power is 3. 3 squared is 9, and 3 cubed is 9 times 3, which is 27. And then 3 to the fourth is 81. So what is our x value equal to? It should be equal to 4. So in this case, x equals 4. So again, I was just showing it doesn't matter what form you're in, you just have to know what each one is saying. Okay, the variables are just placed in different positions. So this is great if we have an exact value, right? Notice that when we raise 2 to the power, we eventually got 8. When we raise 3 to the power, we eventually got 81. But what if it's not exact? What if it's just kind of in the middle of one of those? And that's going to happen obviously more times than not. So what if the value isn't exact? Well, we can approximate. And approximate, we can say, well, it's between these two numbers. And I'll show you what I mean. So look at the first example. 3 to the x is equal to 100. Well, let's start off by just doing what we did earlier and seeing where 100 lies. So 3 to the first is 3. 3 squared is 9, and 3 cubed is 27. 3 to the fourth is 81. We just did this. And 3 to the fifth, let's see if we get 100. Well, 81 times 3 is going to be 243, and that is not 100. But notice where 100 lies. 100 lies somewhere right there, doesn't it? In between 81 and 243. So that means our x values are in between 4 and 5, right? So what we can say is x has to be less than 5, but x must be greater than 4. So that's how we approximate. Normally what we would do is we would put this into log form and solve for it using the calculator, but since we don't have the calculator, this is the best that we can do right now. And just to show you, I'll verify that it's going to be between 4 and 5 by plugging it in as a log. So I'd go to math, log base. Our base is 3 and of 100, and there we get it, 4.19. So we were right, but we have to approximate given the technology that we have at the moment. Okay. Now let's take a look at this. Now this one is in log form, and notice there's no base written. So remember what that means. When there's no base, it's just an imaginary little 10 down there. Okay. So 10 is our base. So what this is saying is 10 to the x power is 700. So again, if you're more comfortable in exponential form, you can go write it in exponential form. 10 to the x power gives me 700. But let's do exactly what we did over here and kind of see what we get. So 10 to the first power is just 10. Oh, that should be a 10, not a. There we go. And then 10 squared is equal, 10 times 10 is 100. And then 10 cubed is just 10 times 10 times 10. The nice thing about being 10 your base, you just add a 0 onto it. So 10 cubed is 1,000. And there we have it. So notice now that 700, the number we're trying to get to, is in between 100 and 1,000. Meaning that our x value should be somewhere between 2, it's larger than 2, but less than 3. So when we approximate it, we'll just write it as such. X must be less than 3, but greater than 2. And that's how we approximate log values if they're not exact. So that's all I have for y'all today. Let me know if there are any questions, and have a good